Welcome to ArcGIS Pro for .NET, Understanding Feature Services, a guide for developers. Beside me is Charlie McLeod, and my name is Russell Brennan. Here's the agenda for today. We'll start with an overview of feature services, what they are and how to create them. Next, we go into a bit more detail of the Pro architecture. We'll discuss the capabilities available to you depending on how your data is stored. We'll then go into some detail on branch versioning, which is our newish versioning architecture. We'll then go into some editing concepts and finish up with some tips and tricks. In this section, I'll be giving an overview of what feature services are and what you might use them for. Feature services are the platform model for feature access. This means the ability to get access to the row data in a table or feature layer, as well as the geometry. This is unlike other services that return images or lightly attributed datasets. This also means the ability to access the data across the platform via web browsers, desktop applications, and mobile-based applications. Feature services are also the sole entry point for long transaction editing using branch version data. Feature services are where we've been focusing our distributed and disconnected workflow development efforts, which allow you to take data into the field, perform edits, and sync back when you have connectivity. Finally, feature services are also the entry point for the platform-wide adoption of utility networks and parcel fabrics, allowing multi-user access to these dataset types. There will be more in the future that will also follow this pattern. A feature service can contain layers and/or tables. Layers have a shape column, tables do not, and both are supported. The feature service allows querying, analysis, and editing of this data. Everything with the feature service is done in a RESTful way, relying on REST requests and responses. Terminology can sometimes be confusing, and you might hear the term web layers or web feature layers when the data lives in a portal. You might hear feature services when in standalone, non-federated servers. These terms can be used interchangeably, and I'll be referring to them as feature services for this presentation. So within a web layer or a feature service, there can be one or many sublayers. The data structures supported by all services include the items I've listed here: points, lines, polygons, relationship classes, attachments. And there are some data sets that are not supported through the feature service, such as geometric networks or network data sets. You can publish the simple data from these data sets, but there's no corresponding feature service layer to describe them. Recently, with the release of the utility network and with parcel fabrics, we now support more complex layer types through the feature service. And as I mentioned earlier, in the future, we expect to extend this as well to other data set types. Feature services are not just about the back-end tabular and row data. The feature service also stores many properties about the layers in the map that you publish. This information and behavior you just get for free when using feature services. And I've listed a number of these properties here. These are properties that you would not get, for example, with shapefiles or with geodatabases. The feature service is accessed through our REST API. Within the feature service REST API, there are operations and resources that are used to perform actions and obtain information respectively. These operations and resources can either be at the service level or at the layer level. Examples of operations are things like querying, editing, calculating. Examples of resources are the service resource, layer resource, replicas resource, things that give you information about the individual items. It is through these that Pro interacts with the server via REST requests. So thus far, I've talked about what a feature service is. I'd like to take a quick moment to discuss how you can create a service. You can share maps via Pro or ArcMap to your portal or your server. You can use the REST API to upload and then publish pre-cooked service definition files. You can use the Python API to create web layers. And via the portal user experience, you have a bunch of other options that I've listed here. The point being that there are many ways to create services depending on your workflows. When working with feature services in Pro, your data and layers should behave just like other geodatabase data sources. Now, this is mostly true, but of course we wouldn't have this session if it were entirely that simple. Mainly as developers, you will write code as if it were any other data store, the main difference being how you connect via the URL to the data. Feature services will support the same types of objects that you would get from other data sources. Charlie?
Okay, thanks, Russell. All right. So in terms of connecting to feature services, the primary way is layer factory and various create layer overloads. You simply provide the service URI. Create layer will return to you a group layer, and the group layer will contain a feature layer added for each layer defined on the service. Any non-spatial data will be added as standalone tables in the standalone table collection at the bottom of the TOC. If the URI you provide to create layer actually points to a specific layer ID, then a feature layer is returned for that specific layer. If the layer ID points to non-spatial data, then you should call standalone table factory create table. At 2.4, we added an additional create layer type, a templated type create layer. And it takes something called layer creation params, as well as a derived feature layer creation params. In this case, simply provide the service URI as the argument to the params. Why use the layer creation params over the create layer overloads? Well, it just gives you a greater granularity over the initial configuration of the layer. So for example, you can specify the initial visibility, the maximum or minimum scales, and so forth. So when you provide the URI to the layer creation params, you set the templated type to group layer, and create layer will return a group layer, same as I described before. If your endpoint URI includes a specific layer ID, use feature layer creation params and set the templated type to feature layer. And that's what I've illustrated in this code snippet here. We have a couple of URIs to a feature service and then a specific layer ID. Notice the commented out URI. It's a portal item URI, so you can use that as well, as long as the corresponding portal is the current active portal. I call create layer. I pass in the URI. It returns to me a group layer for that feature service. I pass in the URI. In this case, this URI includes a specific layer ID, so I am returned a feature layer. Notice the as feature layer cast. Here's this newer create layer using layer creation params. Once again, I pass in the URI, this time as my argument to my layer creation params. And then I'm setting my templated type to group layer. If I had the endpoint URI including a layer ID, then I'd simply use a feature layer creation params, and I would set the templated type to feature layer. Last, you can connect to a feature service using the ArcGIS.core.data API. You use a service connection properties with the endpoint URI, and you provide that as the parameter to the geodatabase. And that's what I'm showing here. My feature service URI, I'm making a service connection properties. I connect to my geodatabase, and from the return feature service data store, I'm opening individual feature classes, and then I'm making corresponding feature layers for each relevant feature class with this layer factory create feature layer overload. Okay, let's go to Pro. And in our first demo, I have a series of buttons here showing different create layer options. So we'll run through them left to right. Create layer 1. So here are 3 different URIs to a couple of different feature services, and then a portal item URI. I call create layer on the layer factory. It returns to me a group layer for that feature service. And then ditto, I repeat with the other URIs. And then notice here, in this case, I'm using the layer creation params flavor. I pass in this case, the portal item URI. And then I'm taking advantage of the isVisible property of the layer creation params to set the initial visibility of this layer to be false. My templated type on create layer is set to group layer. And then in my TOC, I then have 4 group layers created for each of the corresponding URIs. There's the one I created with the layer creation params. Note the visibility is false. If I expand these, you see that they contain feature layers for each of the corresponding layers defined on the service. Let's take a look at Create Layer 2. Once again, a set of URIs. Notice in this case, they contain specific layer IDs. I'm calling Create Layer again. However, it is returning to me a feature layer this time, not a group layer. Notice my as feature layer cast. I've also got an overload here, create feature layer. It does exactly the same as create layer, except it returns a feature layer directly, and there's no need for the as feature layer cast. And then last, I have feature layer creation params. Previously, I used layer creation params, but in this case, my URI contains a layer ID. I'm taking advantage of the renderer definition property on the feature layer creation params to set an initial renderer for this feature layer to be a yellow fill polygon, and that's this color here, red and green. And then my templated type is set to feature layer. So this is my content. Note, I do not have group layers this time. I have feature layers pointing to the individual endpoints I specified. Last option, create layer 3. Once again, URIs. This time I'm using service connection properties, so I'm using the geodatabase. I provide the URI as a parameter. I connect to the corresponding geodatabase, and then from the geodatabase, I'm going to extract the feature classes. I'm manually adding a group layer, and then into that group layer, I'm going to add each feature class I extract from the feature service once I connect using that service connection properties. Okay, so essentially what I'm doing is I'm reproducing that TOC I showed in the first example kind of manually or by hand. So here are the group layers, and then the corresponding feature layers that I extracted from each individual feature service data store. The other thing Russell mentioned was that once you have a feature layer sourced on a feature service, it behaves pretty much the same as any other feature layer. So for example, if I do feature selection, the code for my feature selection is the same as code I would write for any feature layer. I have a spatial query filter. I'm going to query all of the feature layers returned from the first group layer in my TOC. I'll do the select. The first layer is the service territory by ref. I'm doing a selection, contains within the current map extent, and I get no features selected. So nothing in the service territory by ref falls wholly within the map extent. Okay, I'll go to the next layer. Buildings by ref. In this case, I have 65 features selected. I get a row cursor, standard. I move next, retrieve the feature. From the row cursor, I can get attributes, so on and so forth. So standard selection logic. Renderer, change render. I'm going to change the renderer of one of the layers. I'm going to change the renderer of the building's hosted layer. I'll swizzle it to be a unique value renderer. I'll define it on the attribute height. I create the renderer. I set the renderer on the layer. I'm going to change its name from buildings hosted to buildings hosted UVR. And there's the change render. So feature service layers behave same for the most part as regular feature layers. Russell.
Okay, moving into some more general feature service information. I wanted to start here with a general feature service architecture diagram. The top 3 boxes with the blue outline in this diagram are meant to represent ArcGIS Pro and its various components. Within this top group, the very top box is the application tier. The middle box is the geodatabase tier, and the bottom is the feature service client tier. The items in this top group communicate to the items in the bottom group via the REST API, via REST API requests and responses. The bottom box here shows the server, whether it be enterprise, online, or standalone server. It has the service tier processing the requests that are then sent to the data storage tier when appropriate. From a developer perspective, you can think of it this way. The Pro application tier is where you would access editing, mapping, geoprocessing style modules. You can access the geodatabase via the ArcGIS Core data module. The feature service client is more of a translator of any of the calls in the stacks above to the stacks below. So there's no real Pro SDK component for working directly with the client. On the server side, of course, you can interact with the server via REST APIs. This table I put together shows some of the more common translations done by the feature service client. So you can see here that the search cursor maps to the feature service query operation. Editing methods generally map to apply edits. Opening data stores or feature classes map to some of the various resource endpoints. So now into some of the technical details for consuming these services in Pro. A feature service has a layer which has an ID and a name. These names are based off of the layers in the map that are published. And there's no guarantee that the name is going to be unique. You could literally have multiple layers with the exact same name using all invalid characters. I've given an example here on the right. And we do a lot of processing of requests client side. This includes parsing SQL statements. And for this reason, we needed feature class names that would be unique within the data store so that they are parsable. And we came up with this naming convention for feature class and table names. L for layer, followed by the layer ID to make sure that it's unique, and then followed that with the cleaned up name to remove any invalid characters. Okay, so some more notes on unique feature service functionality. As a programmer, you don't need to worry about the cache, but it's good to know about it. We make a local copy of your data that lives for the duration of the Pro session. This data is used for both querying and editing to improve performance. It's a write-through cache, meaning that both the local cache in Pro and the service are updated as edits happen. Pagination is another thing to be aware of with Pro. Pro uses pagination to return rows from the server, unlike our web clients, which only retrieve a limited set of features. Pro will attempt to retrieve all data from the service. For you as a developer, the benefit here is that cursors will appear to be continuous when fetching data. When you get to the end of a page and request the next row, it will just return without you having to make a request for another page. Now, this can appear to give poor performance when working with large data sets, as we will continue to page until we get to the end of all records. So some options to be aware of with respect to how your data is stored when working with feature services. The first option for storing your data is hosted. This is where your data is copied into the cloud or on-premise data store and is managed by the server. The access to your data is thus always through the portal. Hosted data supports the web information model, such as tables, feature classes, relationships. It does not support some of the more complex data sets that I mentioned earlier, such as utility networks or parcel fabrics. Editing from the server perspective are always short transactions, meaning that there's no concept of versioning or versions where you can make edits and do QA before making those edits live. The other data storage option is to use data in your enterprise geodatabase. This is referred to as by reference because your data is referenced by the server and not copied onto and hosted by the server. Like hosted services, by reference services support the web information model. However, by reference services are the only services to expand beyond the traditional information model into more complex data sets. These services support the items I've listed here: versioning, utility networks, annotation, dimensions, true curves, attribute rules. Editing can be either short transactions, like with hosted data, or long transactions using branch versioning. With by reference services, your data will live in an enterprise geodatabase that you manage. And we support feature services on all the most common DBMS platforms. Charlie.
Okay, so given that you may have some content in your TOC, how do you determine which feature layers are sourced on feature service data stores? And the answer is you can use the corresponding geodatabase type. How do you access the geodatabase type? You query the feature layer for its data source, you query the data source for its data store, and then you query the data store for its corresponding geodatabase type. And that's what I've shown in this snippet here. So I've acquired an arbitrary feature layer. I access its data source, feature layer.getTable. From the return dataset, I get its data store. I'm casting to geodatabase, and then I get the corresponding geodatabase type, get geodatabase type. If the type equals geodatabase.service, I'm setting my isFeatureService flag to be true. Okay, so let's use this in our next demo. Okay, once again, I'm going to add some layers into my TOC. Again, a mix of URIs. I'm not going to step through this code. Suffice to say, I wanted to point out that one of my URIs actually points to a file geodatabase, and I'm adding that into contrast with the feature service layers. So there's my file geodatabase, group layers for each of my feature service layers as before. I'm going to execute this general info button, and we're going to query some general information from the feature service layers. Okay, so I'm enumerating each of my layers, and I wanted to determine which are feature service layers, and then I'll query some additional information about them. So I have this custom getIsFeatureService layer method. I'll step into that. So now it looks as though getIsFeatureService layer is actually a method on layer. It's actually a custom method, and it's called an extension method. It's static, and it's in a static class, and has this little keyword this in front of the first parameter. So extension method. And then I'm going to call another extension method, getGeoDatabaseType, from my layer. I'll step into that. And then this looks the same as I showed on the slide. I've got my layer. I'm going to get its data source. From the data source, I'll get the data store. I cast to geodatabase, and I retrieve the underlying geodatabase type. In this case, the geodatabase type is service, and so I'm going to return true. This is a feature service layer. Okay. Because it's a feature service layer, I'm going to query some information, additional information. I'm going to get the layer name. I'm going to get the name of the feature class. So the layer name, that's going to be whatever you specified when you originally published the layer, unless for some reason you changed it when you added the layer into the TOC. The feature class name then, notice that L prefix along with the layer ID. So again, as Russell mentioned, to ensure uniqueness and that it is SQL compliant, that prefix is added to the original layer name. I get the corresponding data connection in the data connection. There's my connection string to the service. And then the data set contains the layer ID 0, the same as I saw in the data set name prefix. Okay. I'm going to loop through all the layers, collecting that information. The only other layer I want to show is the file geodatabase layer. Notice the getIsFeatureService layer returns false, so I'm going to skip this layer. Let's take a look at that code. Back into my custom method. And then notice the getGeoDatabaseType, in this case, returns local database. So it's not equal to service. My method returns false, and I skip that layer. Okay, I pop up that information for each of the layers, each of the feature service layers. So there's the layer name, the dataset, which is the layer name with the prefix L, and then the corresponding layer ID, the URI, and then my little is feature service flag, hard-coded to yes.
Okay. Moving into branch versioning. Branch versioning is a relatively new versioning model introduced with Pro 2.1 and Enterprise 10.6. Branch versioning is purpose-built to support long transactions in services. Has the same basic version types as we had and continue to have with traditional versioning: private, public, protected, and the privileges associated with that. The same basic workflows still apply to branch versioning as with traditional versioning. You make edits, you reconcile, you resolve conflicts, and you post edits. We have made some enhancements to branch versioning. It's timestamp based, meaning you get geodatabase archiving for free. Something unique to branch versioning is the ability to resolve conflicts over multiple sessions. You're no longer required to resolve all conflicts immediately after reconcile. There's enhanced editor tracking for deleted features that does not exist with traditional versioning. And unlike with traditional versioning, branch versioning does not require a compress to be executed regularly. All newer geodatabase datasets will use branch versioning. These dataset types are not compliant or available with traditional versioning. Branch versioning is only available for services published by reference from your enterprise geodatabase, meaning it's not available for hosted services in ArcGIS Online or hosted services in ArcGIS Enterprise. You can view branch version data via a connection to your database, but there's no ability to edit. You must publish feature services if you want to edit your branch version data. It's a single level of versions, meaning that all versions created are children of the default version. We've implemented the ability to change ownership of versions to allow for standard QA processes before posting to default. When we talk about services, we can say that they are secured or unsecured. Secured means you have explicitly shared within your organization or with a group or with no one. Unsecured means that you have shared with everyone. Anybody can access those services. Access to the services, and therefore your data, is based off of the portal or server user. When working with versions, we recommend that you use secured services. Otherwise, you may run into issues where anonymous users can connect, but they can't do certain functions or operations and can be confused as to why this is occurring. With editor tracking and feature services, it's always based off of the portal user, unlike with enterprise databases where it's based off the connected database user. We recommend with branch versioning that you make your default version protected to allow for QA to be done by the admin before posting to default. To use branch versioning, there's a few steps that you need to go through to prepare your data. Add global IDs, enable editor tracking, create a branch connection, and from that branch connection, register as versioned. You then need to add your layers to a map, your feature classes to a map, and enable the version management capability while sharing that map as a feature service. Now you can search for the topic share branch versioned data, and this will give you all the details you need in order to publish your branch version data. This next section is about editing feature services in Pro. For the purposes of this session, we've made a distinction between two types of services that you can work with in Pro: version services and non-version services. This is simply that version services have the version management capability enabled, and non-version services do not have the version management capability. With the version management capability, you'll get long transaction editing behavior, and you can go through the standard versioning workflows I've already discussed. Within these workflows, of course, you have name versions, and these are any version that is not the default version. With branch versioning, these will be any version that's created from default. With these versions, you can create a version from default, edit in that version, reconcile to pull edits from default into your version, resolve any conflicts, post your edits to the default version, and finally delete the version after posting. With the default version, you should note that there's no edit session, and this means that edits are committed immediately as they are performed. There's no ability to undo, redo, or save or discard. There's a locking model that's been implemented when editing version management enabled services in Pro, and this is a single editor, multiple viewer model on named versions. The default version has no locking behavior that you need to worry about. With named versions, this means that multiple viewers can view a version at the same time, but only one user can edit. If two users are viewing, neither can edit until one of them releases locks. Connecting to the data store takes a shared lock. Editing takes an exclusive lock. Saving or discarding edits releases the exclusive lock, and releasing the data store releases the shared lock. So there's a project that we started working on at the end of Pro 2.3, and we were excited that we were finally able to implement it in 2.5. This project was the ability to provide undo-redo for more types of services. So prior to 2.5, undo-redo was only available when working with branch version data with the version management capability enabled. In order to accomplish this undo-redo ability in 2.5, we implemented edit sessions under the covers. One thing to note with this new edit session is that via the Pro SDK or through the Pro UI, you'll get a pop-up the first time you edit one of these services. If you check the box not to see it again, to see this dialog again, the pop-up will no longer show up whenever you make edits to these services. Now, we didn't intend this pop-up to show up in the Pro SDK context and consider this a bug, and we've already addressed it in the current development build, so in the next releases, this pop-up will be disabled for the Pro SDK context. When editing non-version services in previous versions of Pro, your edits were always committed as they occurred. There was no undo or redo, there was no save and discard. For more information on some of the nuance here, you can see our session from last year. I've included this QR code at the bottom, and it will take you to our presentation from last year with some of the more technical details on some editing scenarios in 2.4 as well. So I mentioned a couple slides ago that there were new types of services that implemented edit sessions to provide undo-redo. The new types of services that edit sessions apply to in 2.5 are non-version services. So 2.5, undo-redo, save-discard are now supported. And I need to point out that this implementation is done on the client side in Pro. It is not something that is managed by the feature service running on the server. And I'll get into more details in the next few slides on this client-side implementation. Okay, so let's dive a little bit deeper into what's happening under the hood with these new capabilities for non-version services. Updates and deletes are stored on the client in Pro until the user saves edits. Now, inserts are a little bit different. We need the OID allocated as the edit occurs, so we send the insert to the server immediately. This means that even though the session is managed client-side, inserts can still result in server edits. One thing to be aware of is that the undo of an insert will actually result in a delete being sent when saving or discarding edits. As I mentioned earlier, when saving updates and deletes are sent to the server for each edit. There are some behaviors that are delegated to the service, which I've listed here. Relationship classes, attribute rules that are excluded from client-side execution, and editor tracking. These all occur on the server, and the client delegates that behavior to the server. So this means that you can create relationships, but the relationship navigation will not be available until you save. Attribute rules that are excluded from client-side execution will not kick in until saving. And you won't see your editor tracking values until you save. So we're working currently on resolving the relationship class and editor tracking issues with the client-side implementation, but this might take a few releases before we get these projects complete. So if these delays in behavior, where you're not seeing this stuff before you save, are not acceptable, you can always set the editor options to save every one operation or every two operations to get the same experience in 2.5 that you would have had in 2.4, where everything is sent to the server immediately. Another thing to note is that if you're updating or thousands of rows or performing a lot of edits, the save can take a long time. And you can use this same editor option to auto-save regularly. Mixed mode editing is the default in Pro. When you edit in Pro and you have multiple data sources in your contents pane, you don't need to choose which data source you're editing. This is unlike ArcMap, where you could only edit one workspace at a time. So the contents pane may include data that support edit sessions and some data that do not. Data that support edit sessions will show up on the undo-redo stack. Data that does not support edit sessions will not. And this can lead to an inconsistent UI experience when you're editing both types of layers together in Pro. A final note here about permissions. They're very similar to what you'd see with enterprise geodatabases, but note that they're applied to the service rather than to the individual layer. This means that all permissions on a given service data store will be the same for all of the layers within that data store. Something unique to feature services is ownership-based access control. This is row-level security that allows an admin to determine who can edit individual rows. As a Pro SDK developer, you won't be aware of ownership-based access control. You just won't see rows that you're not allowed to see, and you may get failures when attempting to edit rows you don't have permissions to edit. And now a demo on editing feature services.
Okay. So in this table here, I've summarized some of the editing behavior Russell just discussed. We're talking about feature service layers. So my geodatabase type is service in all cases, and determined as I showed in the previous demo. So we're focusing really on registration type. So there are two types, non-versioned and versioned. Non-versioned then, at 2.4 and before, there was no edit session. At 2.5, there is an edit session, and that's the main change. Versioned splits into two types. Named version of the branch version. Edit session support at 2.4 and before. Edit session at 2.5, so no change. And then versioned, default version, branch versioned. No edit session at 2.4, no edit session at 2.5. So again, no change. How do you determine the registration type? Well, registration type is accessed off the dataset, whereas before we saw geodatabase type was accessed off the data store. Simply query the layer data source for its registration type. And that's what I show here. I've got an arbitrary layer. I query it for its data source. And then the return data source, I query for its registration type, .get registration type. In this case, if the registration type equals registration type .non-versioned, I'm setting my isNonVersioned flag true. If you have registration type .versioned and you want to differentiate between default or named, you go a further step and access the service connection properties of the data store and its version property, check for whether it's the default or named version. All right, let's go to Pro. And our third demo then. Once again, I'm going to add some layer content into my TOC. Same as before, I have a mix of URIs. I'm calling create layer on layer factory. So this is new. I'm using service connection properties. Well, we've seen that. Notice that I'm setting the version property to be the name of a specific version, version A in this case. So this is how you connect to a specific version on a branch version feature service. If you provide the branch version URI, that's what I have here, to layer factory, then by default the connection is to the default version. To connect to a specific named version, you must use service connection properties, the version property, and then I instantiate a geodatabase, extract feature classes, so on and so forth, as I did before in the first demo. So I've added into my table of contents 3 layers, a layer for the non-version feature service, a layer for a default branch version feature service, and then a layer for a named version on a branch version feature service. I'm going to select features in each, perform an edit, and then we'll view the behavior on the Pro UI. So I've got a series of buttons here that will select features in each of the layers. So I'm going to start by selecting some features in the non-version feature service. Actually, before I do that, I just want to point out on my operation stack, I have no corresponding edits. I've got a lot of operations for adding and removing layers, but nothing for edits. And then on my edit tab, notice that save and discard are both disabled. So I'm currently not in an edit session. Okay, I'm going to select some features in my non-versioned feature service. I've got a couple of object IDs hard-coded. I'm extracting the particular layer. I'm doing the selection. All these selection buttons work the same. I'm not going to step through each. There are my 2 selected features. I'm going to perform a move. Move will move those features the distance I have specified in this combo, in this case minus 350 feet or 350 feet to the south. So I'll execute the move. It's an edit operation. I perform move, provide the selection, the move distance. I'm not going to execute or step through this code again. And we see the selected features have moved 350 feet to the south. On my operation stack, notice I have an undoable operation. I go to the Edit tab, Save and Discard are enabled. I am in an edit session, so this is new at 2.5. Non-version feature service supports an edit session. I'll undo the edit. Undo the edit, and then I will terminate the edit session. Let's take a look then at default version, branch version. I've selected these 4 features here. I will move them 350 feet to the south. I go to the operation stack. There is no undoable edit. I'll go to the Edit tab. Save and discard are disabled. I am not in an edit session. Branch version, default, does not support an edit session. Doesn't support an edit session at 2.4 and before, does not support an edit session at 2.5. So I cannot undo these edits. In fact, the only way that I can reverse these edits is to do a corresponding edit to move them back. And that's what I've coded here in my custom undo edits. Okay, let's select some features from our named version, branch versioned. I'll move them 350 feet south. Operation stack, I've got an undoable operation. My edit tab, save and discard are enabled. I'm in an edit session, named version. Branch version supports an edit session, 2.4 and before, and also 2.5. I'll terminate the edit session. Okay. So let's take a look at what Russell called mixed. So I'm going to execute select mixed. Notice I have features selected in all 3 layers. The non-version, the default, and the named. I'll do the move. I'll move the features all 350 feet to the south. Do I have an undoable operation? Yes, I do. On the Edit tab, am I in an edit session? Yes, I most certainly am. I will undo this edit, and I will terminate the edit session. So notice the non-version and the named version both undid the edit. That's because they participate in an edit session. The default version did not. It does not participate in the edit session, and once again, the only way I can undo that edit is to do a corresponding edit that reverses, in this case, my move. So that's the mixed mode. If you have mixed mode edits, then The behavior of the UI is inconsistent. Some things will undo and some things won't. Some edits will be discarded, some won't, so on and so forth. So how do you determine mixed mode? Well, you can use the corresponding registration type. And that's what I'd like to demo here. So I'm just going to select all those features again. And I have a little custom control here that will show in the selected set the varying behaviors of each of the layers. So no undo redo. So notice that's my default version, branch versioned, right? Does not support an edit session, no undo redo. Has undo redo, well that's my non-versioned, it's new at 2.5. My name version, branch version. Okay, I'll go back to mixed mode. I'll enable some breakpoints and we'll see how that's implemented in the code. Okay, let's select has undo redo. I'm calling this custom function here called filter selections. I pass in my selection set. It's all 3 layers, selected features in each. First thing I'll do is I'll clear the selection. And then I got this little custom method here called service layer has undo redo. And in that, I'll step in. We're going to determine if it supports undo redo based on the registration type. So just as I showed on the slide, I get the data source from the layer. And then from the return data source, I get its registration type. My layer is the branch versioned layer, one of the branch versioned layers. If it was registration type non-versioned, I'd be done. As it's the registration type versioned, I need to determine, do I have the named version or the default version? So here's that little extra step. I get the geodatabase. From the geodatabase, I get the corresponding service connection properties, and then I look at the version property. If it's default, I return false. If it's the name version, which it is in this case, I return true. It has undo redo, and so because of my particular toggle and my custom control, I keep that selected set. Next layer, that's going to be my branch version, default version. It does not support undo redo, so I skip that selection. And then the last one will be my non-versioned. I get the registration type. Registration type is non-versioned, new at 2.5. It has undo redo. I return true. And then I'm going to keep that selection as well. So mixed mode, determine it through the corresponding registration type. Russell?
All right. This is the final section on special considerations for working with feature services, otherwise known as tips and tricks. Feature services in Pro can be slower than working directly with geodatabase in certain cases, and we're constantly working on improvements to try to close this gap. This slide is mostly tips for getting better performance from your feature services. So, if you need to get a count of rows, use table.getCount. It uses a much more efficient REST request to the server to retrieve the count info. This will work and perform much better than counting rows via search cursor. For calculating values, use the Calculate Field GP tool. And when you do this, use the SQL option. Using the SQL option pushes the calculate to the server rather than doing it client-side a row at a time in Pro. For bulk loading or bulk updating, if possible, go to the backend geodatabase for appending or updating your services that are published by reference. For hosted data, consider using the append API from the portal. Finally, if you want to provide read-only access to data in your enterprise geodatabase, you can use map services, the sublayers from map services, by adding them individually in Pro. This gives you read-only access to perform analysis without the overhead of also running a feature service. So I mentioned earlier on in this presentation feature caching. So caching is turned on by default for feature services. And for the most part, you should not really need to care about this. One exception is multiple user editing scenarios where users are editing the same data in the same location at the same time. In these scenarios, you may want to refresh the cache to see the latest data in your session. For non-version data, you can simply refresh the map, which will refresh the local cache. For the default version, you can refresh the version. And if the version has been updated on the server, we will refresh the cache locally. For name versions, as I discussed earlier, it's a single editor model, so you won't run into cases where the data is changing behind you. We don't provide a way to refresh the cache in this particular scenario. If this is a common scenario for you with non-version data, there is the ability to disable the feature cache via the layer properties. But the side effect of this is you may see poor performance afterwards. We added the ability to take sync-enabled feature services offline in Pro 2.2. Any service that has sync enabled can go offline in Pro, be edited, and then synced with the server. When data goes offline, it lives in a mobile geodatabase. This means that it is technically no longer a feature service. And while there is currently no SDK for connecting to the mobile geodatabase as a data store, you can still get to the feature class through the feature layer. And keeping in sync with what we did in the feature service, we also added edit session support to mobile geodatabases in 2.5 to allow you to undo and redo edits when your data is offline. Okay, so finishing up, here are some sessions that may be interesting to you that will be available online. And this QR code and URL will take you to this session, the slides and demos. Thank you for listening. Hope to see you next year.